Hi everyone, thanks Jim, thanks for the introduction. So my name is Xavier and the co-founder of FeatureByte, AI-based feature platform. And today I'm going to talk about the challenges of feature engineering, the benefits of feature platform, and how we use generative AI at FeatureByte to make feature engineering even more accessible. So while feature engineering is a critical step to build machine learning models, is still a very challenging task for many companies. So to create and serve features, there are three skills that are essential. Domain expertise help us understand the data and how the different data assets connect. And this makes it that we can come up with feature ideas. Data science skills help us translate those ideas into mathematical forms or code. And it's a time-consuming task, and because the possibilities for features are limitless, and it's a challenging task because there are different types of features that you can create in function of the semantic of the data. Data engineering skills are also essential. You often have to work with extra large transactional data. You also have to work to build the pipelines that are time accurate to avoid time leakage and to ensure training serving consistencies. And also you have to serve the features in production. Google Bard reminds us of another important principle for features. He advised us to create features that are relevant to the use case, and also that advise us that those features have to be informative and interpretable. And while those three skills remain essential, there are two recent innovations that can improve the feature engineering process, the feature platforms and generative AI. Feature platforms offer multiple benefits. So they make the feature engineering more accessible and more efficient in several ways. First, they reduce the latency of feature serving by pre-computing features and storing the feature values in the online store. Second, they prevent inconsistencies between training and prediction. And it is an important result to prevent situations where inconsistencies may affect the accuracy in production. Third, they often simplify the creation of complex features thanks to a declarative framework, and this quite often in Python. Fourth, some feature platform accelerate experimentation by offering automated backfilling, and so there is no log and wait. You can experiment your new feature IDs directly. Fifth, they make it easier to find and reuse existing feature. So this is important to avoid the feature explosion. And finally, they provide a unified solution that makes the transition from experimentation to deployment smoother. So in summary, they make feature engineering more efficient, more accessible, and more accurate. Along feature platform, transformers are revolutionizing data science. They simplify very complex tasks, NLP. So they allow data scientists to transform a text column into new outputs that can be more easily aggregated, like text embedding, sentiment analysis, or extraction of keywords, or extraction of entities. And this work can be done by data scientists by using off-the-shelf transformers without training data, which is awesome results for data scientists. And as a product manager, they're opening a new horizon. They make that product managers can create new data-driven products. There are two personas that may be concerned with transformers. Risk manager may find transformer too new, too opaque, and too stochastic. And MLOps engineers may be worried with the operationalization of the features. So you may have a question: do I still need feature platform for transformers? The answer is yes. They complement each other. Feature platform can improve the operationalization of transformers. They ensure point-in-time correctness. They allow low latency of serving of those features thanks to their pre-computation. And they also give opportunities to reduce expensive transformer calls via partial aggregation or other mechanism, other caching mechanism. Another question is whether transformers will replace traditional feature engineering. Here I'm more skeptical. The use of transformers were successful in some situation, for example, to work with sequences of events, and so there were successful results for recommendation system. But the use of transformers on a larger context, on many more columns, and that are less well defined, the problem is more challenging. And even if a solution emerge, there will be less magic than for NLP. It won't be pre-trained off-the-shelf transform that you can use directly, but you will have to train those transformers on your own data and use a lot of data to get meaningful results. And for many of us, it may not pass the model validation process because of concerns of explainability, and also concern on the robustness if the data is not enough large. So why do I think transformers are still revolutionary as a product manager? What I particularly like with transformer is their ability to work with semantic, to understand semantic and connect semantics. And I think it's a result that we can use to improve feature engineering. In feature engineering, we are working with many different assets and concepts that contain semantics. And there is opportunity to use transformers and generative AI to connect all those assets together. So I will give some examples of how generative AI can help feature engineering and build and how he can help create those features that Byte advise us to create the relevant, informative, and transparent features. So when we work on the FeatureByte Copilot, we made 3 key observations. First, we found that generative AI is already very familiar with data modeling concepts. They understand what are the best practices in data modeling. They understand what is a slowly changing dimension table. They understand what are entities. They also can recognize the semantics of data columns well beyond numeric and string. If meaningful names and good descriptions are provided. And it's again a very important result because these allow to connect columns together and make appropriate choice of type of features to create from those columns. We also found that generative AI possesses deep domain knowledge for many different domains. And this can help take some important decisions in the feature engineering process. And it also gives the opportunity to use generative AI to assess how relevant a feature is to a use case. Here I'm giving a simple example. So we all know that there are different types of numeric columns, and some columns cannot be added together. And a good example of that are grades or any measure of intensity. And it's a concept that generative AI understands well. So I'll just ask him what I can do with whether a speed column is additive, semi-additive, non-additive, circular, or categorical column. And he finds that the speed column is non-additive and reminds me that the non-additive column cannot do any sum on the non-additive column. So you cannot do sum of the speed of the cars in the city. It won't be it may be correlated with your target, but it won't be a meaningful and robust feature. Another example how generative AI can help you in feature engineering is so sometimes you have columns in your tables that represent the event type. So here we have the example is with a credit card transaction table, where we have a transaction type with 7 types. And I can ask generative AI which type of transaction is the most meaningful for the use case of fraud. And generative AI is capable to make good recommendation and advise me to first focus on purchase transaction, then on cash advance, and then on reversal transactions. And will tell me that bank fees features will not be useful for this use case. Another relevant result is that generative AI can give plain English of explanation of why a feature is relevant. So it can provide a more detailed description of the features, explain what is the score that was used by this feature, can give examples, and can also assess whether these features is relevant to the use case. And here he gives a score of 9 out of 10. And generative AI is also capable to do this even for complex features. Here is a diagram how FeatureByte Copilot is currently leveraging generative AI. So we use generative AI in 2 areas. First, we use generative AI to understand the description of the data, the description of table, columns, entities. And also we provided the description of the use case, which domains this use case belong to, the context and the target. And the generative AI is capable to make sense of all this information and map these to our ontology. And this information is used as an input of our feature ideation engine that suggests features with code and description. And we again use generative AI to evaluate the feature and assess its relevance. And the result is a context-aware feature suggestion, where we sort the features by their relevance. We provide the explanation found by generative AI, and also we organize the results by categorizing the signal type that was captured by the feature. So you can either choose to add those features directly to the catalog, or generate notebooks to have the SDK code related to this feature and edit those features to create similar features. Here I give a link of examples of feature SDK and notebooks that we provided in our tutorials. This is my conclusion. So feature platforms and generative AI are accelerating data science in 3 ways. First, they reduce time to value, thanks to quicker experimentation, thanks to backfilling. Also, by reducing the manual work, you reduce the effort. And we saw that feature platforms allow a smooth transition from experimentation to deployment. They also, the two innovations combined increased production accuracy. We saw that training serving consistency is important to ensure that the production accuracy is aligned with the production that you got during validation. And there are opportunities to create better features. One with transformers by doing a better NLP from a text, and also by getting better feature suggestions that are context aware. And another important outcome of those innovations is that they enhance transparency and give the opportunity to bridge the gap between features and non-technical stakeholders. Thanks to plain English descriptions of features and their relevance to a use case. I think is something really important to achieve a broader adoptions of AI in companies. It's important that non-data scientists can understand well what we are doing, and this transparency can improve, increase the trust that those non-stakeholders give us. So that was my last slide. Thank you for sharing with me this experience, and yeah.
Thanks very much, Xavier. Fascinating stuff. And I think you're doing some really innovative work here on Gen AI.